Let's talk about the continuity of this function here, this piecewise function. So we're going to use the top piece when x is strictly less than 3, and we'll use the bottom piece when x is greater than or equal to 3. And of course the interesting value here is what happens at 3. So let's talk about the continuity of this function at x equals 3. So condition number 1 is, here it is right here, is f of a defined, and a in our case is 3. So we want to know, is this function defined at 3? So let's see what happens here. F of 3, well, according to the instructions here, when x is greater than or even equal to 3, we're going to use this bottom part of the function here. So we're going to write this as negative 3 squared plus 6 times 3 minus 8. And be careful here, negative 3 squared, this we're squaring the 3. We'll get negative 9 plus 18 minus 8, and this comes out to 1. So condition 1 is satisfied, and I'll write that over here. So condition 1 is satisfied, f of a is defined. In fact, f of 3 is equal to 1. Let's check condition 2 now. What we're looking for is the limit of this function as we approach 3. Right now, as we approach 3, let's look at what happens as we approach from the left, and then what happens as we approach from the right. So let's take a look here at what is the limit as x approaches 3 from the left of f of x. And as we approach from the left, we're below 3, so we're going to use this piece of the function right here, right? Because we're approaching from the left, so we're at values less than 3. And if we're less than 3, we're going to use this piece of the function here. So we're looking at x minus 3. So if we put 3 into here, we're going to get the absolute value of 3 minus 3, the absolute value of 0, which is 0. So as we approach from the left, we're approaching 0. Now let's look to see what happens as x approaches 3 from the right. And as we approach from the right, we're at values, right, approaching from the right, we're at values bigger than 3. So bigger than 3, we're going to use this piece of the function right here. So what we're going to use then is negative x squared plus 6x minus 8. And if we put 3 into this polynomial function, we'll get negative 3 squared plus 6 times 3 minus 8. This turns out to be 1. So now let's check the left limit and the right limit. The left limit is 0, the right limit is 1. These are not equal, so condition 2 fails. The limit does not exist. So I'm going to state that here, why it's happening. Since the limit from the left is not equal to the limit from the right, we're going to conclude that the limit does not exist. And because the limit does not exist, that means condition 2 fails. So I'll write that right here. And now let's make a conclusion. Let's say that because condition 2 fails, that this function, our original function, is discontinuous, whereas not continuous at x equals 3. So I'm going to write that. So we will say, because continuity condition 2 fails, f of x is not continuous at x equals 3. And once again, we're not just saying f of x is not continuous, we're giving our reason for it, because we're saying because continuity condition 2 fails, that f of x is not continuous at 3.